the last lecture we have seen some problems. In continuation of this, we will be seeing some more problems. So let us start a new problem. The problem states like this. A cyclone separator is used to remove sand grains from an airstream at 150 degrees centigrade. If the cyclone body is 0.6 meters in diameter and the average tangential velocity is 16 meters per second, what is the radial velocity near the wall of the particles 20 and 40 micrometers in size? Basically, cyclone separator is a device which is used to separate solids from a gas. So this gas here in this example is air, and the solid particles are what? Sand particles. And the size of the particles is what? 20 micrometers and 40 micrometers. And you know that 1 micrometer is equal to 10 to the power of minus 6 meters. So we have the feed which is entering the tangentially to the cyclone separator at 16 meters per second, and the feed is also having air which is measured at 150 degree centigrade. Now what we are supposed to do is we are supposed to find what is the average tangential velocity or radial velocity of both the particles which are sent into the cyclone separator along with the feed. And the solution for this problem is, we have a cyclone separator here as I have drawn this. So sand grains plus air enters the cyclone separator, and then the air will be going from the top, whereas the sand grains will be coming from the bottom. If you see the top view of this cyclone separator, it is a circle in nature, and the diameter is given as 0.6 meters. We are supposed to convert all the units to SI systems, and the unit of diameter measured in SI system is meters. So it is 6.6 meters. Then the tangential velocity is given as 16 meters per second. Then the first point, the diameter of the particle 1 is 20 micrometers, which is given as 20 into 10 to the power of minus 6 meters. And then second particle is 40 micrometers. It is given by 40 into 10 to the power of minus 6 meters. And we know one formula, V is equal to R omega, where V is equal to tangential velocity measured in meters per second, and R is the distance between the center of the cyclone separator and center of the particle which is moving along the walls of the cyclone separator. And omega, or the radial velocity, is measured in radians per second, which we are supposed to measure. Then as I said that we have a formula for the particle 1. If you take dp is equal to 20 micrometers and omega is equal to V tangential velocity by R, and R is what, sir? Here I have drawn this diameter. This is the total cyclone separator. Its diameter is given by D, and here I need the distance from this point to this point, so it is given as R, and then R, it is also denoted as D by 2, and we have a particle here along the walls, that is the particle number 1 whose diameter is dp is 20 micrometers, and I need the center of these particles to the center. This is the meaning of R. So R for the first particle is equal to 0.6 meters by 2, because this is the total diameter, and half the diameter is what? That is 0.6 by 2, and the center of this particle and from here is what? This total distance minus R of the particle. This gives this value, and if you calculate it, it is coming as 0.29 radians per second. In the same way, we are supposed to find the radial velocity for the particle 2 whose size is around 40 micrometers. It is given by this formula. So with this we come to the end of the problem number 7.8.